To be able to implement different functions onto our model in-game, we need transform groups, which we call functional nodes. Depending on where we place such a point or node, we can assign a function to this node with the help of i3D mapping via XML. Let's dedicate ourselves to our attachments coupling so that we are able to attach the cultivator with the 3-point hitch. To visually create a little space to work with, we mark all our collisions and can make them invisible with the key H. To be safe, we set the cursor to the 0 point again with Shift+C. In object mode, we create a transform group via add, empty, plain axis. Name it attachable via double-click and then move it with Shift and left mouse button inside our scene collection as a child of smaragd9_vis. If we select the transform group and then press Ctrl+C to copy, we can insert 2 more transform groups by pressing Ctrl+V twice. Let's rename the 2 transform groups to Attacher Joint and Top Reference Node, which we both move to Attachable. Now we should move the transform group so that Attacher Joint is centered between the catch hooks of the lower link and Top Reference Node is at the place where we want to attach the top link. There is one special consideration. We need to rotate the attacher joint 90 degrees on the y-axis so that we can attach the cultivator correctly in-game. This is a requirement of the game. Make sure you set the orientation to local beforehand. As we already know in Blender, the z-axis is the height axis, and so we should be careful whilst proceeding. If we want to move something in the Giants editor on the z-axis, for example, animations, we have to specify the y-axis in Blender in translation direction. Mentioned again, the z and y-axis are swapped between Blender and the Giants editor. In addition to the attachment points of the lower and upper links, we need to add the power and hydraulic connections. In the main collision, we select the hoses, which have to be visible if the cultivator is detached. We go into Edit mode, select all the necessary faces, separate them from the rest, open Object mode, and move the hoses into our attachable transform group. To keep the hierarchy complete, we add another transform group, name it Connection Hoses, and move our separated mesh of hoses into it. Here we should turn this object into 3 separate hoses. This gives us the option to hide or show the hoses individually when attaching them later. It is very important to set reasonable names and assign them to the objects or transform groups via Node ID or i3D mapping before exporting. We choose electric O1 underscore detached, hydraulic out O1 underscore detached, and hydraulic in O1 underscore detached. Thanks to the possible shared objects that are in the base game, we can load unified models of connectors from our game folder. Here we need to set transform groups that we can reference later in the XML with i3D mapping. We have to rotate them on the x-axis so the direction will fit later. We choose the names electric O1 underscore detached adapter, hydraulic out O1 underscore detached adapter, and hydraulic in O1 underscore detached adapter. Followed by this, we will have to specify the nodes where our hoses will be displayed once a vehicle is attached. We can hide our previously edited hoses by selecting them and pressing key H. Now we have to select the hoses that are still present on the model. Select Edit Mode and use the Edge tool to select the center of each hose and add a transform group with a matching name to each hose using the cursor. The names chosen here are electric O1, hydraulic in O1, and hydraulic out O1. By now, it should be a habit, but again we need to add the node IDs for the i3D mapping. As of now, we have created all the necessary connections for the attachment. In our case, the individual hydraulic and electrical connections as well as the mechanical 3-point hitch. Next, we'll have a look at something specific for our implements. Each implement has a specific work area. To do this, we create an empty transform group in our main model and name it Work Areas. Inside the created transform group, we have to add 3 more transform groups: Work Area Start, Work Area Width, and Work Area Height. Work Area Start is placed sideways at the front left corner, where the cultivator should start cultivating. We use 2.5 here because the cultivator has a work width of 5 meters. Work Area Width is placed on the opposite side, with the value of minus 2.5, so the difference of 5 is given. Work Area Height is positioned in the same way as Work Area Start, just move it further back. With these 3 nodes, the game can create a parallelogram to define the work area. Last but not least, we add the node IDs for the i3D mapping. To tell the game if our device touches the ground, we need to create another transform group called Ground Reference Node. In addition, to use effects from older farming simulator releases, we need another transform group as well. We call it Depth Node, and can use it in our games to reflect the depth of the device in the ground and thus adjust the size of the soil effect. We attach both nodes to the bottom of our cultivator, in our case at the bottom end of the coulters. With this, we can finalize the work areas and start making the compatibility between the cultivator and the AI worker. To start, we create a transform group, put it again in our main tree, and name it AI, abbreviated for Artificial Intelligence. To simplify the step, we can copy our work area start, work area width, and work area height from before and paste them into the transform group AI. There we rename the work area start to AI marker left, work area width to AI marker right, and work area height to AI marker back. But AI marker back should be centered on the x-axis. We can copy the 3 transform groups in AI again and rename them like this: AI marker left to size marker left, AI marker right to size marker right, and AI marker back to size marker back. Size marker back has to be moved to the end of the implement to be able to define the total size of the attachment later. If we define these transform groups later in the XML, our AI or AI worker knows how large our work area or working width is, also knows the size of the entire implement, and can ultimately use it to maneuver more or less reasonably. In order for our AI worker to stop, we need to create a trigger from a mesh. We create an object, raise it by 0.5 meters, and drag it in width, so it's wider than our model. We name the mesh AI Collision Trigger. Give it the necessary attributes for the special trigger via Physics, Trigger AI Collision Trigger, and click on Apply Selected. The AI Collision Trigger is there to let our AI worker know when a person, another vehicle, or an object is in front of the device and stop before the person is run over or an obstacle is hit. Finally, we should not forget to set the i3D mapping for the objects.